Hello, my name is Ian, and I'm going to talk about Krazy Karaoke, our final project for EC551. Unfortunately, we couldn't fully integrate all the modules together to form the full system, but we have a lot of the components working, and we will show you how the system would work had we had time to fully integrate everything. The first thing is an audio signal is captured by the microphone, which goes into the custom circuit designed to meet ADC input voltage requirements, which is biased around 0.5 volts. Goes into the ADC, which then converts the signal into digital and sends it to block RAM. And then block RAM sends it both to the FFT module and the PWM conversion at the same time. And the FFT module we'll talk about in a second, then the PWM conversion goes out to the mono speaker. The frequencies are fed into two FIFOs. The first is the reference FIFO, which is filled as the user records the reference track. And the second is the song FIFO. When the user switches banks, it'll record to the song FIFO instead. And each of these FIFOs is getting a frequency after it's been transformed. And then each frequency is popped off of the queue as long as there's one on each queue by the score module, which then will score them based on our scoring algorithm, send out a score, tally the score, and then that score is then displayed on the VGA. The VGA itself is divided into grids, which correspond to each bit that is in a register. So the 5x5 pixels for the top and bottom portions, and then there are 16 rows. And then the middle portion is 20 by 20 pixels, and this is one changes dynamically with the score.
One of our biggest hurdles was figuring out how to condition an analog audio input for use with the onboard ADC. The screen capture here shows you the waveform of a song that we were sampling, and as you can see clearly, the peak-to-peak voltage is out of specification for the onboard ADC. We were able to correct that via an analog circuit, really just a voltage divider, and you can see here the max peak-to-peak was around 0.95 volts, which is acceptable, and really in general the on average the input voltage was not really very close to 0.95 volts. The figure on the left demonstrates sort of the core operation of what an FFT in hardware looks like. And you see the sort of butterfly operation that's very recursive and friendly to hardware. And then on the right is a very, very high level depiction of how this might be implemented in hardware. So at a high level, the way this system is designed to work is step one, downsample the sampled analog audio data to 41.1 kilohertz. Step two, push that to a FIFO to some memory that also concatenates the samples into an 8-sample frame, which is then popped to the FFT. The FFT conducts its analysis. And step four, we find the max frequency, i.e. the pitch of that frame based on the output, and then that information is sent to another memory block to await scoring. This is a schematic of my implementation of the FFT, just the FFT block. You can sort of visualize the butterfly operation and the recursion just from a high-level perspective of the schematic. Ultimately, though, this is a complicated operation, and a number of resources were utilized. Much of this code was generated via Simulank's HDL code generation tool, which maps sort of block diagrams to HDL code.
Now I'm going to demonstrate the scoring module and VGA display. For the purpose of the demonstration, I added some buttons and frequency loader module. What that does is it loads a frequency every clock cycle into each of the FIFOs, the reference frequency FIFO and the song frequency FIFO, just for demonstration purposes. So the first set will be identical, so you score full points. The second set is too far away, A4 to E4, so you score 0 points. the third set is the lowest possible points of 5 points, because again, they're pretty far apart, these two notes, A4 and G4. And then this shows how the score does not need to be perfectly on the note, but within a range. So you still get 10 points for that, A4 to A4. And then this shows how this is technically in between an A4 and an A sharp. But yeah, so you'll get partial points for 7 points. And then if you sing just a note half step up, or it will be also partial points. So the average score at the end should be a 6. And if we look at the simulation, you can see that first score is a 10, average is a 10, 0, goes down to 5, 5, 10, turns it to a 6, and then there are 2 7s, and then it just stays at 7 for the rest. Okay, so we have our initial screen, which is showing a 0 because the tally is still 0. So in the FPGA, the center button here is the start button. So I'm going to push start, and it goes to 6. It's really fast because it's a 100 megahertz clock, but you can push reset, go to 0, and